All right, last example in this section. Let's find at least two equations for this graph. All right, I'm first going to draw the midline because this is shifted up. So the midline is going to come through here. It's a little crooked, but that's okay. I'll redo it. The midline is here. And so we've got to figure out where to start and what to do. So I think the easiest way to do it would be to treat this as a sine and start right there. That would be treating it as a sine with the phase shift is 0. The amplitude is 1 because that's the distance, here. But if we're treating this as our starting place, we're going down. Amplitude's 1, but it means A is going to be -1. And then we need the period. Let's see, the period, if we go from here to here, the period is 2. All right, so let's see, period's 2, so that means 2 equals 2 pi over b. So that means b is pi, because you get 2b equals 2 pi, so b is pi. And then the phase shift is 0, so c is 0. So this one's pretty quick. We just get y is equal to negative sine of bx, so pi x plus c. C is 0. So we get that, and then we also have to remember it's shifted up, so we've got to add 1 onto it. All right, let's go ahead and find another one, and then we'll graph them both at the end. All right, let's do one that's a cosine. We could pick to start here or to start here. It doesn't matter. Let's start at this one. It really doesn't matter. Okay, so if we start there, so if we start at that purple point, the phase shift in that case is going to be 1.5. The amplitude, well, the amplitude's still 1. If we start there, though, we're starting at the top. So the amplitude in this case, well, the amplitude's 1 and A is going to be +1 because, cosine starts at the top. So we're starting at the top there, so A is 1. All right, and our period, the period is still 2, and I'm not going to go through this again, but we still get B is pi. So let's solve for the phase shift. Remember, phase shift is equal to C over B. So we get 3/2 equals C over pi. So that gives me C is 3 pi over 2. So this gives me y equals A, which is 1, cosine 3 pi over 2. Wait. That's my C. B, cosine pi x, then minus 3 pi over 2. And I'm leaving a little extra space there because I have to add on the vertical shift of 1. All right. So let's see. Notice something about this. These are the same, these two equations, they give us the same graph. So there are a couple of things that have to be the same. They have to have the same value of b because b completely determines the period. And the amplitude, notice this one has an amplitude, well, they both have the same amplitude of 1. So A has to be the same number, although the sign can be different. And also this vertical shift has to be the same. The only things that can really change are the in order for two things to have the same graph, the only things that can really change are the phase shift, the function switching between sine and cosine, and the sign of A, whether it's positive or negative, not the S-I-N-E. All right, let's graph both of these and first off see if they're the same, and then see if they match the graph that's over there. All right, so this first one, let's see, minus sine, let me actually give it a name, y equals minus sine pi x plus 1. And the second one was y equals cosine pi x minus 3 pi over 2. That's a minus, not an equal. Plus 1. Sweet. Those two are the same. Now let's compare them to this. Let's see, this point right here, it goes through at 1 and goes down. And the period, let's see, we'll check the period by looking at this. This is 0, 1. This should be 2, 1. If I can get it to, it doesn't want to lock onto it. But that is the point 2, 1. And over here we have the point 2, 1 here. So yeah, those are correct. And you know, if we had nothing better to do, we could come back and say, okay, let's make one that starts here or starts here or whatever. You know, you can start it anywhere you want it. And the only thing it's going to do is change, possibly change the sign of A, and it'll change the phase shift. So anyway, I think that's enough for this. We'll stop here.